Ciao, everyone, and welcome to Spazio, a monthly series that highlights Italy's enduring role in the space ecosystem. I am your host, Kelli Kedis Ogborn, and to our viewers all over the world, good morning, good afternoon, and good evening. Today is episode 3, where you will get to meet the faces behind two of Italy's most innovative companies that are transforming the landscape and carving out a new heritage for Italy within the new space ecosystem. Joining me today is Renato Panesi, who is with Deorbit, as well as Francesco De Stefano from CARACOL. Renato is an entrepreneur with a strong background in B2B marketing and sales and is the founder and chief commercial officer of Deorbit. Renato identifies as space addicted with his academic history rooted in aerospace engineering and a PhD in advanced flight control systems. He also received a Fulbright scholarship to attend the Technology Entrepreneurship Program at Santa Clara University, which is in California. And he also took courses and seminars at UC Berkeley and Stanford. Professionally, Renato has experienced both the private and civil space world, both US-based and abroad. He interned at NASA Ames Research Center in Mountain View, California, and worked for the multinational aerospace and defense firm Leonardo as an aerodynamics and flight control system engineer, project manager, as well as marketing and sales area manager in the Asia Pacific region. In 2011, he co-founded Deorbit and started working full-time for the company in 2015, assuming the role of Chief Commercial Officer. Renato, we're very happy to have you join us today. Joining me as well is Francesco De Stefano, who is an entrepreneur with significant international exposure and extensive background in management and strategy, as well as deep knowledge in the industrial goods sector and Industry 4.0 technologies. After studying business administration at Bocconi University and London Business School, Francesco joined the Boston Consulting Group in Milan, where he consolidated and deepened strategy and operations capabilities, working for 7+ clients in industrial goods with a focus on automotive and aerospace. And he also worked closely with major international automotive conglomerates to roll out Industry 4.0 technologies across their production lines. He mastered his managerial skills by completing an MBA at Columbia Business School in New York. And he founded CARACOL in 2017 and is currently the CEO, where he manages their growth and global operations, overseeing all activities related to fundraising, strategy, commercial, finance, and operations. Gentlemen, thank you both for joining me. And I don't know how you sleep. You both have very big jobs and your companies are doing incredible things to really transform the space ecosystem. So I'm very much looking forward to this conversation today.
Thank you, Kelly. Thank you very much. And allow me also to thank both the Space Foundation and the Italian Trade Agency Houston office for allowing me to be here to present my company, what we do, and what we want to do.
Absolutely. I mean, it's our pleasure. I always say that I have the fun job of just getting to engage with really interesting and smart people and help tell their stories. So it's easy for me. I'm happy to have you on. So as a starting point, because we have a lot of different narratives and a lot of different projects that you're working on, I want to give an overview of both of your companies, what they do, how they intersect, and really how they're growing within the space ecosystem. So Francesco, why don't we start with you and tell us a little bit more about CARACOL, what you do, how long you've been in operations, and some of the key projects you're working on.
So first of all, thanks a lot, Kelly, and I join Renato in thanking everyone for the invitation. It's a pleasure to be here. Getting to the question, what is CARACOL? CARACOL operates in the additive manufacturing field. So we are a company that actually started back in 2015 with a research project in order to try to address the problems that were related with the production of large parts, very big parts. We're talking about from a meter up to 15, 20 meters. And we decided to explore the advantages of additive manufacturing and came out with a new technology that was integrating additive manufacturing, 3D printing with robotics in order to print very big components. Our main sector is aerospace, but then we also work for automotive, marine industry, as well as other important industries in the industrial and also in the creative industry space. The company from its founding back in end of 2017 and beginning of 2018 has grown a lot and went through 3 different fundraising rounds. And today we are based in Italy, but we are opening our international expansion in the US market as well as in the Middle East market.
That's great. Thank you. What about you, Renato?
Well, as you said, Kelly, the Orbit was launched in 2011, so we are 12-year-old now. We count 273 people as we speak. Our headquarters is in Lake Como, Italy, and we have subsidiaries in Portugal and UK. We are a space logistic company. Actually, we have been one of the first mover in this field, this new market. For us, space logistics means taking care of customer assets in space from the very launch with our launch and last mile delivery services, during the operational life with in-orbit servicing, which means refueling and therefore life extension, which means repositioning in case of drift or whatever, small repair, or even simple visual inspection, and end-of-life management when there's nothing more to do on satellites. I have to say that when we launched the company in 2011, we understood that something around the space community was changing. We were not aware to be among the pioneers of what later has been called space economy. We were among very few companies doing that, and raising capital at that time was super tough. Venture capital fund, except for few exceptions, were more looking at faster return on investment, smaller amounts to invest. Space from that point of view is very challenging. So at the beginning was very tough, but at the end is paying off. And I'm super happy that my company has been launched in Italy. As you said, I did study a lot in the US, and I could have decided to launch the company in California, where I used to live. But I decided to go back to my country and do something in Italy, of course, because I am Italian, but also because I think, now I can say I was right, we have all the ingredients in this country. We have a very strong academic tradition, very strong and prestigious universities, and we have the full value chain. We are among the few countries in the world with the full value chain covering the ground segment, the launch industry, the satellite manufacturing, and all the related value chain with a lot of expertise. So I'm super happy. This doesn't mean that the company is Italian. We have 17 different nationalities working at the Orbit. We are very, very proud of it, and looking forward to big things.
I want to expand upon something that you said, because it's really an interesting point that I think is worth remembering, is that both of you are in these really critical industries that are very much a linchpin to the growth of the space economy. So when you talk about additive manufacturing and composites and manufacturing in space, and when you talk about all of the stuff that you do at D-Orbit with in-service operations like the ISAM portfolio, these are really critical to expanding business opportunities in low Earth orbit and beyond. And I like the point that you made, that when you launched the company, those capabilities and maybe use cases weren't as prevalent as they are today because the landscape is rapidly evolving. Could you both touch upon that a bit more, about what that's been like in terms of knowing that there was a need when you initially launched the company, and then now seeing all these growth potentials, both from investment and customer base and use case?
I don't know, Renato, if you wanna go first, but maybe I can touch upon a bit of. I wanted to build on what Renato said before, because for us, in a different segment, we operate in we are behind the curtains of the space industry. So we manufacture, we support companies like the Orbit in order to find new ways of manufacturing their space assets and reducing the time to launch. And for us as well, it's in a different way, but it's been tough to actually convince investors, VC investors, to invest in manufacturing companies that had such a deep vision into the space sector, for example. But I think we were lucky enough to be a bit let's say younger than the Orbit, because we found specialized investors. Well, at the beginning when they started, they didn't have that privilege to have those specialized investors, and I think they have helped a lot. Maybe I can comment a bit on us. I think from the beginning we realized that additive manufacturing is such a powerful tool for the space industry. I think we all know that it allows to have very complex production on very few volumes, and compared to the mass industry where other technologies maybe might be very interesting, it allows to have faster lead times and digitalize the supply chain and allow for high customization, as well as it gives the possibility actually to drastically reduce the weight in some cases of the space assets that there need to be launched. And of course, that means cost for companies like the Orbit. So at the beginning, we realized straight away that that was not exactly possible because qualification issues, a different type of obstacles were not fully allowing to unlock that potential. And by delivering a very target mission towards manufacturing for the space applications and all the certification that goes beyond with that, and working side by side with OEMs like the Orbit as well, we were really truly able to master a lot of new applications and new technologies that can really help increasing the rate of volumes of space launches.
Yeah.
Yeah, I
Yeah.
agree. And I think that, Renato, from your perspective, because, when we talk about unlocking business opportunity in low Earth orbit, a lot of what's discussed is the launch equation. So being able to get rockets that are cheap, reliable, ubiquitous, routine. But really, the backbone of it does come down to additive manufacturing, but then also the logistics and transportation services that you're doing at deorbit. Because once you get things up, what do you do with them? And so I'm curious what your perspective from that transition has been in terms of use case and interest.
Well, yeah, of course, I agree with what Francesco said before. When we launched our company, we understood, I mean, not just us, but we were among the one understanding that the big cut in cost on both manufacturing satellite and launching them would have opened the doors of commercial space, not just to government agencies or very big corporation, but also to small enterprises, and also to countries not even aiming to launch one single small satellite to space up to that point.
Mhm.
So the market was changing, and the forecast about the number of satellites to be launched and the way to operate them, not just big single satellites in geo with a 15 years expected lifespan, but constellation of dozens, if not hundreds, of satellites in LEO with a shorter operational life, working together in a constellation. So this exponential demand of launches would impose at some point the need of a logistics service, because this infrastructure somehow needs to be launched properly, planned properly, and maintained properly once in orbit. And with so many constellations and so crowded orbit, it's also important to get rid of that satellite, of course, because of the space debris issue, of course, because of sustainability principle, whatever, but also for commercial needs, because you need to provide orbit clearance, making the operational slots free for the replacement satellites when the old one are almost dead. So there is a commercial needs of logistics. How to make it work is what keeps me awake at night.
Yeah.
And we work on this with also with our competitors. We are actually joining efforts to provide a common service in the future, because if we want to serve any orbit, we really need a fleet of servicing modules already there when the customer calls for a service, and we can do it alone. We need partners. When you drive and you get a flat tire, you get your insurance company, you call them, and they send the local workshop to repair your car. You don't care what workshop is involved. You just care about having your car repaired. And this is what we want to do with our partners. The end users call, whoever player has the nearest vehicle will go there and serve. It's a kind of code share service, call it that way.
No, that analogy is actually perfect, because it's a very easy way for people to grasp. And what's interesting about the satellite proliferation, as you mentioned, and just the need in the near term, there was a statistic that I learned recently that just talked about how many satellites are planned to be in orbit in the next 10 years. So I think the equation was that between up until 2020, there was about 2,500 satellites orbiting. Between 2020 and 2022, that doubled to 5,000. And in the next 10 years, they expect it to be about 100,000 amongst the different orbits, just with the, advent of a lot of these low Earth orbit constellations. And so it just continues to show that the value chain, like you said, it's very near term, but it's only going to continue the delta is going to continue to increase as these capabilities come online.
That's a trend.
Yeah, very much a trend. And it's causing, ripple effects across the whole industry. And I know you guys intimately feel it.
And every mission, of course, has a degree of customization, because we are still talking about space. On every mission, we add a degree of complexity. On every mission, we try to reduce cost. And this is why we love to work together with companies like CARACOL. Their technology is amazing and can be very helpful for us when it comes to designing structural parts, tanks, critical parts of our spacecraft, because in that way we can save on cost, we can save on mass, we can streamline the production, lead time of components can be shorter. So it's a continuous, recurring improvement.
And I think just to build on what Renato was saying, and thanks for that. I think it's the key obstacles that we see in achieving that vision of larger volumes or larger launches, larger constellations, is the fact that, as Renato was saying, customization is calling for new manufacturing solutions. And of course, additive by itself cannot fix that if not combined with the key end users that own the requirements that can drive you through the certification processes. So I think the importance of working side by side between the space economy players and the manufacturing, new technologies and new manufacturing players, it's what's really driving innovation within the industry. Because if a couple of years ago we were not thinking possible the idea of building the bus structure of a satellite with another manufacturing solution, today we see that a lot of space companies out there are starting to implement these technologies, and it's coming at scale. So I think by working side by side with the space industry key players and the manufacturers of the technology and the developers of the manufacturing technology, we really create that synergy that allows to increase the volumes and reduce the cost of flying.
Absolutely. You guys just got a shout out from the comments from Firefly Aerospace in Houston. They said if you need a launch service, reach out to them and you can coordinate operations. So that's great. So Francesco, I want to pull the thread a little bit about the impact and the importance of additive manufacturing. And I know you touched upon it, but really this is going to be truly transformative to enable a lot of these products and services and capabilities that we want to see. So can you talk a little bit about that, and particularly around why it's important to reduce time to flight?
So, I mean, generally speaking, exactly for what we were saying, additive manufacturing has some key advantages for that are usually collected into having more design flexibility. For example, with our technology, we work on 6-axis, so the geometrical complexity of the components we can do is really much more flexible than a traditional CNC milling technology that is used for milling metals that are then come on a standard structure of a satellite, for example. It allows you to fully customize and digitalize every single part without having increasing cost. So if the orbit wants to do one of their Ion space carriers in a way this time for this launch, because they have some payload they need to customize from. This time you can do it in a way, the next one is going to be done slightly different, you still have the same type of cost. So flexibilizing the cost structure through digitalization allows you to fully exploit additive manufacturing and therefore reducing the cost. And of course, all that customization would require, for example, if you start using molding for some specific plastics, or you start using CNC milling, it requires time. Lead time would be much higher. You would have several parts that are joined together. With our technology, you print it in one piece, straight from one job through the one digital job, and just deliver the final part in a matter of days or weeks. So that is the way that we iterate much faster. So from their engineering, their design, we are able to getting into a programming file that gets into the machine digitally, and out of the machine itself, given the larger working bounding box that you have, you get the final part in an integrated design, thanks to the complexity of geometry that the technology can reach. All these factors all together reduce the engineering and design time, reduce the manufacturing time, and therefore shorten the lead time to get them the component that then is embedded into the rest of the system and then ship and launch in the space. So this way, you really, on the one hand, you reduce the time to market, so that the development time of a new platform, as well as you reduce the manufacturing time of their existing platform, allowing for larger customization. So I think these are critical, and it's true for composites part as well as metals, because we have the possibility to switch between two platforms right now.
Yeah, and I
Yeah,
imagine.
Francesco is perfectly right. He mentioned our Ion satellite carrier, which is our orbital transfer vehicle,
Mhm,
through which we provide last mile delivery
mhm.
service for host satellites on board, from drop off orbit provided by launch provider to whatever target destination orbit is in LEO. We typically run ride share missions, so we have multiple payloads on board. It's not a plan. We are actually doing it. We have 11 successful missions in our track records. The point is that all payloads are different. So you need proper mechanical interfaces, highly customized to host all of them on the same mission. And you really have a short time to do that, because the time passing in between the contract signature with customer and the delivery of the carrier to the launch provider for qualification and launch campaign is very short. Therefore, we need an effective solution for whatever mechanical interface we need. And this is where additive manufacturing is of help. And specifically, Francesco, your wire arc manufacturing technology.
Yeah, and also I think also when coming into in-orbit services, that is going to be even more important, because
Yeah.
Exactly.
I mean, I think we're going to touch upon, but like in-orbit manufacturing is not only a dream. I think it's possible by
I,
joining the two
it's just
capabilities. Yeah,
it's right beyond the corner.
yeah.
It's also being bet on as one of the 10 economic drivers of the new space economy by Morgan Stanley and these other big financial banks, that the manufacturing vertical, but particularly additive, really driving the growth arc. And you both touched upon the customization aspect, both from a business perspective, for you, Renato, being able to grow, but I imagine also just capabilities down the road that we might not necessarily even know are going to be needed. It allows that transformational value chain, using that term again, to be able to provide. And I would question, because I'm not actually quite sure for you, Francesco, but does additive manufacturing also allow you, with the basic composite structure, to create tailored metals and tailored parts and properties that might be needed for future space systems?
Absolutely. I think what we were discussing before is the idea that thanks to data, and more, the more we develop the machine, the more we are able to achieve that. Thanks to data, you're able to get into the engineering project of the customer and embed it into the manufacturing file, and being able to manage, for example, the infills, the filling of the part, based on the type of structure you need, both on composites and metal materials. So this type of elements becomes crucial, because we need to keep the weight as low as possible, but the structurality as high as possible. So thanks to that, we are able to really tailor the part, not only on the geometry, but also on the way we deposit material in order to fulfill the requirements.
Absolutely. Before we go into a couple more mission sets, we actually have a question that is relevant to this part. and I believe it's going to apply to both of you in different ways, but they ask if there's any sort of international legal modifications or changes that you need to operate.
Well, I can start.
Yeah.
This is a very tricky question because in-orbit servicing implies a rendezvous maneuver and a docking with a third-party satellite. So you need whatever authorization on that side. Satellites are registered on one specific nation, but they also registered in the nation of the launch provider who launched them into space. They can report in some cases to multiple different nations, and in order to provide in-orbit servicing, you need all the proper authorization in place and all the insurance paperwork in place. Otherwise, it would be like a declaration of war, which leads me to the other aspect of in-orbit servicing, which is related to defense application.
Yeah.
And I think this is more the angle players like Northrop Grumman are aiming at with their application, because you understand that if you can get close and grab a friendly satellite, you can do that with a hostile one to steal information or jam it or whatever. But yes, there are some law requirements to be met. We are working at European Commission level with other companies to promote, to help promoting an international law, and then we need help on having nations ratifying an international agreement.
Yeah.
I think of course, the main question I think was for Renato on flying, but I can touch upon standards on manufacturing for space industry. I think that's important as well. So the European Space Agency has been issuing some standards on additive manufacturing. So there is a common standard for some specific applications in Europe. NASA is doing the same. They kind of have a joint draft of that. There are small differences. I would say that 80 or 90% of the requirements of the parts that need to fly in space are similar. Then, of course, there are some difference based on the application, and based on the different type of space vessels that you're actually keeping with.
Yeah, I think this question, dovetails into broader questions that are postured just around property rights in space and all of these other, this budding area of space law and activities, because the activities we're going to see are going to be very different than what we've normally seen in terms of scientific missions and exploration, because there's actually going to be commerce and business activities that are going to be, geographically spread. So it's a good question to ask. And Renato, I think you broke it down nicely about who owns what and how the distinctions play. That was a really helpful, layout.
It will also be a huge amount of data to send to ground, to process. We could spend 1 hour talking about the need of cybersecurity it's
Maybe that'll be like a part 2 to this that we could get on. While you're on this thread, though, talking about in-orbit service missions, I know that you guys are part of a pretty big consortium that's led by Thales Alenia Space that's around this aspect. Can you talk a little bit about that, what your involvement is, and why this is historic and important?
So the program comes from a specific requirement from the Italian government to have our first national demonstration mission of in-orbit servicing, including a demonstration of refueling, of small repairs in orbit through proper robotics, repositioning, and eventually even atmospheric re-entry. The procurement agency is the Italian Space Agency, and Thales Alenia Space is leading the consortium. We are part of it together with Spazio and Avio and Leonardo. Thales Alenia Space will design and manufacture the so-called Chaser satellite. We are in charge to design and manufacture the cooperative target satellite. based on our ion carrier technologies. Telespazio will take care of the ground segment, Leonardo of the robotic arm, and Avio of the propulsion models. As the orbit, besides designing and producing the target, we will be in charge of maneuvering the target, except during the rendezvous, close approach, and docking operation, during which we will stay passive. And after docking, we will be responsible of the refueling demo, which will actually be liquid exchange of liquid or fluid in between the chaser and the target as a demo of refueling application.
As a large-scale demonstration of all of these different components, is this the first time that this is trying to be done?
There are several attempts. I don't know whether this will be the first in history, but it will be historical for Europe.
Yeah.
The launch is planned in 2026, so just 3 years from now. So it will be a first. If you talk about the first in-orbit service demo in history, that has been done by Northrop Grumman, but not involving all of these activities together.
Yeah, all of the totality of the different components coming together.
Correct.
Yeah. No, it's a very exciting project. And when will the demonstration be done, so you know if it's successful in the different areas?
So the launch is expected in let's say, end of second half of 2026,
Okay.
with a mission actually occurring in the first part of 2027. I would expect a 1 year duration for that mission. So yeah.
That's great. Well, and I think what's exciting about it is, there's so many Italian companies that are involved in this, and I know that from an ESA perspective and an Italy perspective, there's a lot of money being put into investment in in-orbit servicing, but also they're doing a lot of different grand challenges, I believe, that Italian-led with ESA that your companies are part of. Could you touch upon some of those projects as well?
Yes, I have to say that besides the specific requirement from the government, and that mission I didn't mention will be in LEO orbit.
Mm-hmm.
At the last ESA ministerial, November 2022, Italy also did put 60 million euro to develop at ESA level a GEO in orbit servicing mission, and other countries did also contribute, and so the I can mention Germany, I can mention Spain, I can mention UK. So with this amount of money, ESA took several initiatives within the so-called Clean Space initiative programs. Several feasibility studies have been done by companies like us, but also companies like Astroscale or ClearSpace or Telespazio. We are now going into the next phase through which development programs will be funded, and we are working to have our GEO in orbit servicing vehicle development funded, targeting an initial mission by 2028.
Okay.
I have to say the GEO orbit will be the real place where in-orbit servicing mission aimed at refueling, life extension, repositioning, the market will be there. In LEO, except for few specific cases or strategic needs of a country or a specific company, the market will be more about end-of-life management. Because satellites being launched to LEO are conceived and designed to have a short operational life, and they're replaced with state-of-the-art payloads. So,
yeah, that's a really interesting distinction to make, because it's true. They're different mission sets, different lifespans, different construction. What about you, Francesco, in terms of your ESA work on any of these grand challenges or any of the projects they've put forward?
Yeah, I mean, on our side, all this happening means new capabilities in terms of producing some of the customization. I mean, robotic arm that Renato was mentioning is just one of examples in which probably you need to use an arm in order to pick, and one day you will need to use an arm in order to repair, or you could use an arm in order to manufacture some components that you need for spare parts in an international space station. So all that is actually a line of research we are following in CARACOL, and together with the orbit, and we got into a grand challenge with the European Space Agency with the idea to actually find a way to evolve our process for microgravity or no gravity environments. So having the possibility to actually have robotic arms printing in space directly components that could be starting from metals, but with composites as well, in order then to perform some of these applications in the future. So the challenge is still open. So we are asking SMEs and research centers and universities to apply to get some ideas and to join forces with us and ESA in order to accelerate this development.
I have a comment to that, and actually a question from the chat. So that component about robotic manufacturing in space is really going to be a critical aspect to be able to truly unlock a lot of opportunity. Because when you look at the evolution, being able to take Earth out of the equation in a lot of ways and having to manufacture things on Earth, bring them up to space, and rely on launch capabilities. While it will be quicker in the future, it's not going to enable the exponential growth that we're all expecting. And so, Francesco, from the chat, a question for you is: can you elaborate a bit on the importance of materials when it comes to working on space-related projects, and in particular, how you're researching and adapting to those advanced requirements?
That's a very, very important question, because I think in that lies a lot of the barriers that we need to overcome in order to make additive manufacturing accessible for space companies for real. And with the orbit, a lot of the work we've been doing, for example, on wire arc additive manufacturing and the recently launched technology that we launched in the market thanks to the collaboration with them, is actually starting from the same materials that are already qualifying in space, because we're talking about different type of aluminums, for example. It can be other type of titaniums in some specific applications. So the materials are important. The good news is that we are not reinventing the wheel there in many cases, because there are a lot of materials that are already qualified for space. The difference is the process. So you need to go through the same type of a different type of manufacturing process. You're adding layer on layer instead of milling, for example, some aluminum that is qualified already. So the qualification process, and a lot of the work we've been doing in researching, is doing some mechanical characterization, different type of in-orbit testing, in order to see how the process performs on the same material and which type of requirements it can guarantee in terms of structurality. So the work we do side by side with companies like the Orbit is really get the requirements that today are fulfilled thanks to a material or to a specific process, engineer the design, because it's so important to change the design based on the technology you use in order to manufacture, using the same type of materials or adapting the alloys to the new process, and then going through some qualification processes in which you do mechanical testing, chemical testing, and then in-orbit testing as a last step in order to fully qualify the technology, and knowing that that is actually added to the portfolio of manufacturing possibilities that a company like the Orbit could have.
Yeah, it probably just continues to add to your catalog, right,
Correct.
of possibilities. Yeah.
That,
Renato, do those requirements, how do you look into the future to be able to inform companies like CARACOL?
It will not be an easy life for them because requirements change continuously and quickly, and the requested lead time are shorter and shorter. But this is a strong point of additive manufacturing, right? And then you mentioned in-orbit manufacturing before. So there will be one big thing occurring earlier than just in-orbit manufacturing, which will be in-orbit recycling. And to such an extent, we will need materials easy to be recycled and a technology to be used in space to recycle them. And I think the additive manufacturing is one of the winning technology with that regards. I'm not the expert, Francesco is.
no,
So I
you're totally right, Renato. I think the way we handle, for example, like our robots, the way they're fed on composites, it already allows circular economy on Earth. Why not in space? So there
Exactly.
are challenges related to the environment in which we recycle or manufacture parts, but the key in the heart of the process is already to be fully sustainable. So it really goes well in hands with the mission of actually recycling or reducing space debris or satellites at end of life.
That is a really critical piece because we talked about the satellite proliferation, we talked about the need for maneuverability and sustainment and manufacturing aspects, but the space junk that already exists and what you do with it and how you handle it, I know is a critical aspect that's been pervasive upon the regulation of sustainability in the ecosystem. But from an entrepreneurial or a company perspective, I think there's a lot of opportunity in that area as well.
Oh yeah.
um, Before I kind of ask my final question, I want to get to a couple more that are in the chat because there's a lot of really good engagement. But Renato, I believe this one is for you, but it's essentially saying, are you looking for different options in order to choose your launch site, or where you launch from, rather?
Absolutely, yes. We do it already as we speak with our in-orbit transportation services. We need to provide a service which is recurring, regular, uh, covering several different orbits. For example, our, let's say, Southeast Asia custom requests mid-inclination orbits, which are met only by specific launch providers. um, our vehicle are being designed to be compatible with all of them.
Mm-hmm.
So if you worth, the answer is yes. We did it already in the past. We did launch with PSLV. We did launch with Vega. We will launch with Vega C. We are currently using Falcon 9. Ariane 6 is in pipeline, and we uh, are also betting on selected newcomers, provided they have a vehicle big enough to host our platform. And we think there are several promising players like Space in Germany, for example. We are we decided to bet on them and purchase a launch, which will be the third commercial launch in their manifest. So this is something I can announce, but there are others all around the world, of
That's
course.
great. So, in closing thoughts, because we're running up on time, because it's been such a great conversation, I know that your companies are already future leaning in many ways, and you're really enabling growth within the area. But I would be remiss if I didn't ask you, what are your growth goals? So, looking at, the next 3 to 5 years, you both talked about current missions that you're already involved in, but what do you really hope to accomplish for your companies? And this could be new technological capabilities, new mission sets, just kind of anything for your closing thoughts.
Francesco, you want to go first? Otherwise, I can start.
Go for it, Ron. Yeah, for
Okay.
sure.
So, of course, it goes without saying, being our first in-orbit servicing mission scheduled in 2026, that will be one main goal. But another next big thing we want to reach is a full speed commercial service when it comes to cloud computing. We are already doing some tests on three of our vehicles, and we think that cloud computing will be one of the next big thing, because the bottleneck of sending raw data to ground with a very slow data link, processing them on ground, compared to processing data on board and send to ground only the commercial relevant information. Uh, there's a big difference in time needed, which has a commercial value for several industries, talking about, for instance, oil and gas, but also for public institutions for disaster prevention or monitoring. So we know, we don't just think it will be a big thing, because of the several companies started working on that as well. And we have top tier partners in this, like AWS and Unibap. So I think we are well positioned to deliver a good service in 3 years from now.
Yeah, and that's a
And
fantastic focused area. Like you said, very timely and very necessary. What about you,
yeah,
Francesco?
super important. I totally agree with Renato. I think if you connect that with manufacturing data as well, that's and touches upon a bit of our vision. So for us, we want to be having installing a network of robots all over the world that are producing large parts directly closer to the site. And imagine having the parts being produced really almost at the launch site in order to eliminate logistics all over the world of very heavy and very complex parts, has a sustainability impact, a time impact, as well as a cost reduction impact. So for us, it's really creating a distributed network of robots that are digitally integrated. They are monitoring, equipped with a lot of sensors and monitoring assets in order to gather data, and thanks to AI and other elements, to actually become as smart as possible in order to improve the process and guarantee more and more critical requirements. That is going to start on Earth, but for sure, I'm sure it's going to be integrated in some of the space assets that companies like the Orbit are going to bring up there.
I've loved this discussion because you both have such a fantastic, optimistic view and innovative approach to really enabling where we all want to see the space economy growing. So I want to sincerely thank you for sharing your time and expertise with us. And really, I'm excited to see what comes for your companies in the next 6 months, 3 years, 10 years, 15 years. And I want to thank our viewers for tuning in and really for engaging. Those have been really great and thoughtful questions. Mark your calendars for our next discussion for Spazio, which will be August 24th, where we are going to talk about Italian space clusters and innovation hubs, and particularly dive into who they are, what they do, and who the new players are on the horizon. Thank you so much for tuning in, and we will see you next time.
Thank
Bye.
you.
Thank you.